Oh my goodness, I can't see a thing. Oh, good. We can now see. We got our glasses on. We're ready to teach. Good. We got our sound working. Oh, no one at the door. Just want to go over some stuff for percents, parts, and wholes. This is 7 in 4, lesson 2. The part equals percent times the whole. We're going to review a little bit of 7 in 4 lesson 1, and then we're going to dive into lesson 2 and see how we can use this powerful construct and some other structures that can help us solve some pretty difficult problems. So let's see where this gets us. We'll do some samples out of the lesson 7 in 4 lesson 2 out of the problem set. We'll also work a few problems that are just off the top of my head that kind of apply and teach the concepts. Okay, so whoops, what did we do here? I'm kind of lost for a second. I need to switch over to let's go. Let's switch over to our screen, and yeah, there we are. All right, good. Cool. Make this screen a little bit bigger. All right, so 7 in 4, lesson 2, part, percent, whole. So let's just start off with this part, percent, whole equation and just get into this a little bit better, remind us where we've been. And the whole idea is that the part, this is the whole idea. Percent times the whole. And this percent, as you recall from lesson 1, it must be percent as decimal. Whenever we're working with percents in equations, or almost all the time, we're using the decimal version of the percent. So a percent as decimal, as you recall, just to connect our prior learning. So if we say 75%, that's 0.75 as a decimal, right? We're moving that decimal 2 to the left, so we're kind of going bop, bop. Oops, 1, 2, and then our decimals here. So we get 75% is 0.75. Similarly, 42% is 0.42. Now, tricky if we have something like 1%. Remember, we kind of have these imaginary zeros. 0, 0, 1 is the same thing as 1. So that helps us know that 1% is 0.01 and not 0.01. If this is tricky, and let's just do the last one, like 300% is 1, 2, right? So that's equal to 3. So these are our numbers as decimals. If you have any difficulty with this, you need to understand this before you move forward. And similarly, we have to know how to go backwards. So like 0.64 is 64%. It's moving the decimal the other way too. 0.05 is 1, 2 is 5%. And 396 is, 3.96 would be like 396%. So you need to know all of this before proceeding forward. Okay, so now that we've recalled this little transformation, we can go into our part equals percent times whole equation and work a few quick problems, and then we'll get into the more difficult ones. So if we know, this is 3 things, right? We have our part, our percent, and our whole. And if we know any 2 of them, we can find the third thing. If we know 2, then we can find the third. So let's just do a few of those. So part equals percent times whole. So if we know that we have what 72%. Let's start with the whole. Let's say we have 400 kids, and 25% of kids are in 7th grade. So our whole is 400. Our whole is 400 kids. We have a total of 400 kids, and 25% of the kids are in 7th grade. So our percent is 25%. And remember, whenever we deal with percents in this equation, it must be as a decimal. So that's 0.25. And what we don't know is the part. What part of the kids are in 7th grade? So the question is, what part of kids are in 7th grade? So we write the equation, part P, it could be X, we'll call it X, equals 0.25, remember our percent as a decimal, times our whole, 400. And you can, calculate this out and you can get X equals 100. And because it's a word problem, we have to label it. 100 kids in 7th grade. And we box our answer. Now, that's one way that you can use the equation. Sometimes we know the part, and say the percent. So an example of this would be there are, this is example 2. So we have 24%. Let's do 40. It's easier to calculate. 40% of class are girls. The class, there are 24 girls in the class. How big is the entire class? So we have a lot of keywords here that help us know that our part is our 24 girls, and the entire class would be the girls plus the boys. So in this case, our part equals 24 girls. And we have our percent, which is equal to 40%, and as a decimal, that's 0.4. So our equation here, we have part equals percent times whole. So we have 24 equals 0.4 times x. And now solving this, we have to go back to 7m3, and this is a one-step equation. We divide both sides by 0.4, and we can type that into our calculator, and we can, I think we're going to get 60, and we say yes, x equals 60 kids. And that's in the class because that's our whole, and we label our answers. All right, so that's just the basic version of how we do part, percent, whole, but we're going to use this, we're going to use a new structure. This is part 1. So this was part 1 of our lesson. Now we're going to move on to part 2 of the lesson, part 2. And in this lesson, this part of the lesson, we're going to learn a new construct, and the construct is going to be a picture that's going to help us solve part, percent, whole problems. It looks like this. It looks like this. Okay, so this is going to be our, these are going to be our numbers. And these are going to be our percents, our numbers, and this is going to be our whole, and this is going to be our part. So just bear with me while I draw this picture, and it'll all hopefully start to make sense soon. And we'll do some problems. And this will be our parts. And this will be our whole. Okay, a whole, and we discussed this in 7M4 lesson 1. Our whole for a percent is always 100%. 100%, right? This represents, so let's go into a mode where we start labeling some things. This is 100% is all. Now let's look back at our example that we just did, where we had 400 and we've had 400 kids, right? So we had 400 kids. This was our whole. And we had 25% were girls. No, 7th graders. 25%. And these were our 7th graders. So this 7th grade. And this was the rest. And this is what we were given. This color, you know, that's kind of what we were given in the problem. Now, the blue will be, you know, this is what we solve. So we can just kind of see where we started. 100% is always, always, always given. So that's why that's in red. But everything else is going to be, that we're given is in this kind of greenish brown color. So I'm colorblind. So if this is some other color to you, just bear with me. And just assume this was greenish brown. Now, we always are going to have this interesting, or these mathematical truths whenever we deal with these type of problems. And we have, these are always two-part problems. We have one part that is one thing and one part is the other. And we have this number part here, and it's going to go here. The number part here, right? The number part that's 25% will go here. And our number part that is the rest will go here. And our percentage part that is our 7th graders, or one part goes here, and the rest goes here. The rest percent goes here. And we can start to fill in any of these three boxes whenever we see something that seems obvious to us or easy for us to follow. Now, there's 4 different equations that all work out. The first one is that the part plus the part equals the whole. You know, kind of 1 is the part plus the part equals the whole. And that makes sense. If we have 400 kids and part are in 7th grade and the rest are not in 7th grade, we can add those two together and they should get to 400. Well, the same goes for percent. If part, and I'm going to say, you know, 2, the percentage part plus the percentage part, now this always equals 100%. 100% is all. So if 25% are in 7th grade, the rest must be not in 7th grade. And we can do this in our head, right? We know that if 25% plus some number is 100%, we can actually go ahead and fill this in, and we know that's 75%. That's an easy one. Now, the other 2 equations are kind of hidden, but they connect back to what we just learned. We have this part equals percent times whole, and we have 2 of those equations. One of them is here. and one of them is here. This is so cool. We have 3 part 1 equals percent part 1 times the whole. And then 4 part 2 equals percent part 2 times the whole. Okay, and now all we need is 2 out of 3 on any one of these. Now realize we had these two on this percent part plus the percent part equals 100. We had 2 out of 3 there, so we could easily fill in the percent part 2. I could even go ahead and label this percent part 2 and percent part 1. Now we can look at any equation where we have 2 out of 3. Well, we can't do the part plus the part equals the whole because we have 2 empty spots. But we can do a part 1 equals part 1% times the whole, or we can even do part 2 equals percent part 2 times the whole because we have 2 out of 3. So let's do part 1 equals percent part 1 times the whole. We'll do that in red, and we'll say, well, we'll do it in blue because we're going to solve everything in blue. So we said part 1, we don't know. Part 1, we could have called it x. We could call it part 1. We call it any variable. This is just a very long variable name. Equals 25% times 400. Well, we always have to make sure that those are written as decimals. And so we get 100. 0.25 times 100, 400 is 100. So we can put 100 in here. Now, there's 2 ways we can go about solving for this last piece. The easy way would be the part plus the part equals the whole. 100 plus what is 400? And we know that's 300. But we could have also used our part 2 equation. Whenever we have 1 spot left, there's always 2 ways we can solve it. So let's see if we would have solved it the other way, if we'd get the same thing. Part 2 equals the percent of part 2, 0.75, times the whole. And it turns out if you multiply those out, you do get 300. So we have a nice consistent answer, a nice consistent picture. 25% of the kids are in 7th grade, or 100 of the kids are in 7th grade. And the rest is 300, or 75%. Now let's put this powerful construct to work in a few examples from lesson 2. You might want to take a screenshot of this, save it, come back to it. I'm gonna bring up a new picture, and we're going to do this one more time. So we're going to look at number 4. This is going to be on S.11, number 4, and we're going to see how this powerful construct can help us solve the dartboard problem. So Curtis is throwing darts at a dartboard. And he's throwing 15 darts. He throws 15 darts total, right? He throws 15 at the dartboard. Numbers, whole, part, percent, part, whole, and these go together, and these go together. And let's see what we can. We know that the whole percent is always 100%. So let's see if we can figure this out. We got 15 darts total. So let's kind of put this number where, you know, some of these numbers, well, let's write it out, and then we'll put the numbers where we think they go. 40% hit bullseye. He's a pretty good shot. 40% hit the bullseye. And we want to know how many did not hit the bullseye. So we got to think about what we're doing here. You got to put your, you know, here we have to use, you know, what they call critical thinking. I can't tell you how to I can only give you examples. Critical thinking is built by you as you do more and more problems. So we have to think about what is the whole. So I'm going to ask you some questions, and you should form an answer to this. Don't just wait for me to tell you. What is the whole? What is the whole? And what are the parts in this question? Well, there's two parts, and let's just do English. Well, the whole is he threw 15 darts total. Some hit the bullseye and some did not. So the whole is the number thrown, and the part is the ones that hit the bullseye. You know, the middle. The bullseye on a dartboard is that, you know, is that middle spot, and then you have rings that go like this. You know, he hit that bullseye 40%. He's a great shot, and then 60% did not. So we can label our part one as hit the bullseye, and the other part did not. Now let's just start to fill in our numbers. So you had 15 total. So that's a whole. 15 darts. Now some hit and some did not. We don't know how many did or didn't. The problem doesn't tell us. But we know that 40% hit the bullseye. So on our percentage side, we're going to put a 40% here. But they want to know how many did not hit the bullseye. So they want to know this answer. Well, we can't answer that directly because we don't know what percent did not hit the bullseye. We don't know how many hit the bullseye, so we can't subtract. We're going to have to do a two-step problem here. So let's start to solve it, and we'll solve it in green here. And so what do you want to do first? The things we can find is we can find the number that hit the bullseye, because we can use a part equals percent times whole with these three pieces here, right? We can go these three pieces because we know 2, and then we can find this one. Or we could find maybe this piece here, and then we can do a percent equals part times whole problem. Well, let's do it by figuring out this piece right here. Well, we know that if 40% hit the bullseye, then the total number of darts has to be 100%, then this has to be 60%. That's got to be 60. 40 plus 60 equals 100. Now we can use our part equals percent times whole to solve for this. So our part, which we don't know, is equal to 0.60 times 15. And that equals 9 darts. So 9 did not hit the bullseye. Did not. And we can do this other one. We can do it, this how many hit the bullseye, we can do it 2 ways, but I see it easy to do as a subtraction problem. If 9 did not, then 6 did. And you could do the math, and you could say the other way to do it would be our part equals percent times whole, our unknown equals 0.4 times 15, and if you multiply that out, you're going to get 6. So the answer, though, to the problem is this is what they were looking for. So 9 did not hit the bullseye. Okay. Oh, let's do this one. I like this one. So we're going to do one more. I said we'd do 3, but we're only going to do 2. And so this last one is number 6 on S.11. And this is Matthew scored 168. Matthew scored 168 points this season. 147 points in regular season. And then the rest in the playoffs. And the question is, what percent did he score in the playoffs? So I'd like you to draw, your hole and your percents and label them. Okay, so now I want you to, fill in. So here's your numbers. And here's your percents. And we know this is always adds up to 100%, our two parts. So you need to figure out what is the whole, what are the parts, what do we know, and then let's leave it in green. So try and fill this in, try and solve the problem. I'd like you to fill out all the parts here and then see what you come up with. Okay, now hopefully you've solved this by now. Just scribbled out some good answers. And let's see. So first of all, let's label these two pieces. Well, we have the regular season. He scored points in the regular season and he scored points in the playoffs. All right, so we have, the regular season is part of the season, the playoffs are the rest, and then we have our total. So he scored 168, that goes here. That's the total points for the entire season. He scored 147 in the regular season. So now we can start to solve the problem. Maybe if you didn't get this right, let's fix it up, pause the video, and then try and solve the rest of it. Okay, so now in the playoffs, he scored, well, if he scored 147 in the regular season and 168 total, he must have scored 21 in the playoffs. Well, that's neat. So now all we have left to do is figure out our percent. So our percent part whole equation works like this, right? Our part equals our percent times our whole. So let's look at this guy. And let's say, well, our part is 21. Our percent, we don't know, that's X. And our whole is 168. So we're going to take, and so to solve for X, we got to divide by 168 on both sides. 21 divided by 168 equals X equals 0.125. Now that's not, this is our percent as a decimal. Percent as a decimal. So we have to convert that by moving our decimal 2 to the right, and so that's 12.5%. So our answer, 12.5%. And that leaves in the regular season, well, it's 100%. The regular season plus 12.5% has to equal 100. So in the regular season, he scored 87.5% of his points. So the answer is 12.5% of points scored in the playoffs. And you know what? I don't know what I've been doing. We're going to, Happy Cat has been meowing and, missing me, missing us all, loving to help out with these problems. And when he gets meow, he gets so happy when we solve these problems. He can't stand it. So, wow, another Happy Cat popping up here. We're going to just box our answer. We're going to say 12.5% is our answer to number 6. And if you have any questions, feel free to email me, cowboy.lipscomb@gmail.com. You can comment on this video in YouTube. I can extend the lesson if necessary. I can explain things if you don't understand them. Let me know how I can help you learn any of this information. I'm happy to do more more lessons, extend this lesson, more examples, or explain anything that may have been confusing. So, wow, thank you for that applause. I love this. I love doing this. All right, I will talk to you later. Happy math. Happy cat.